Industrial load manipulators are largely used in production and logistics environments. However, manipulating moderate loads, up to 70 to 80 kilograms, is quite cumbersome with current systems. The daily manipulation of these loads in a non-ergonomic way has mid-term and long-term consequences into musculoskeletal conditions such as muscle pain, joint fatigue, and so on. When combined with the aging workforce, these issues result into long absenteeism on the production floor.
In the range of all the components that we use, specifically we were focusing on the mid-range in terms of weight. This means between the 5 and the 25 kilogram. Why this is specific? Because normal persons, they can handle these parts on a day a couple of times, but if they have to do this for the whole day, it can be a strain for the back and the arms.
And that's of course where Smart Handlers projects came, to develop innovative technologies that can make it ergonomic and easy to manipulate load in the daily operation.
The Smart Handler project targets developing innovative technologies to make it ergonomic and easy to manipulate moderate loads in operational environments. The research team started with a human-centered requirements approach where operators are directly asked about their daily challenges for loads manipulations. These inputs are used to derive loads manipulation cycles and key performance indicators, KPIs, to improve such as muscles forces and body postures. Technological concepts were then analyzed to improve these KPIs. The Follow Me concept gets a good ranking in this analysis. This concept consists of predicting operators' intents to manipulate the load and activate a mechanism to help operators on manipulating these loads.
Simply explained, we're measuring the angle that the chain is making, and in that way we predict what the operator is willing to do, so where he wants to move the load. And in that way we can control the bridge, so we can actuate the bridge in order to reduce the operator forces. So we do this by compensating the inertia of the bridge, and also we compensate the frictional forces in the system.
While the Follow Me concept is designed to reduce muscles forces, researchers explored in parallel ergonomic designs of gripping systems and human-machine interfaces to improve body postures.
What we have also explored is a kind of hands-free human-machine interface that operators can wear, for instance, in their hands, and therefore make their two hands as free as possible to focus into the load manipulation.
These technological components are then integrated in an industrial manipulator and tested in lab conditions with one-axis and two-axis systems to prove their genericity. The system proved reduction of muscle forces and cycle time by a factor of ×2. With Tiltech as an integrator in the project consortium, the Smart Handler system was moved to the next level to further increase its industrial maturity.
We have, together with Flanders Make, tried to find a solution for the customers. So they have the technical knowledge more towards programming, electrics. We have more knowledge towards what the customer needs, what they want, and we are specialized in rail systems. And when we brought those two together, we found a good solution, we think.
After different improvements iterations, and with the approval of an ergonomist, the system was further improved and installed at different end users' production floors. As we start with operators' requirements, the project consortium insisted on closing the loop by letting operators test these industrial proof of concepts in their environments. It was important for the project to get feedback from operators in their daily use. We used the System Usability Score standard to collect this feedback. Some operators gave a high score, proving the added value of the system, while others gave it a low score, looking forward to further improvements in the system with the integrator.
Although we are just in the phase that we get used to the system, we have seen already that indeed, if we use the system right, it helps us to have a controlled way of accelerating and decelerating the whole system. The ultimate proof will be if the operators are happy on this line, they will tell it to the operators of the following line, and then the people will come to us and ask, can we have the same system on other lines?
Besides these technological achievements, the project showed, with relevant partners in the value chain, advantages and challenges of moving a technology from a research idea to operations in production environments.